I'll do a video about it. So there are two, this is a protractor. There are two measurements. This is the outer measurement right here. And this right here is the inner scale. So outer scale's here and inner scale's here. Makes sense, right? This is the outside of the protractor. This is the inside of the protractor. So the reason why they have that is sometimes you're going to be measuring from this side and sometimes you're going to be measuring from this side. So if you're measuring from this side, this is where your 0 starts. Can you see that there's a 0 right here? So it's not going to be 50 degrees. It's going to be 130 degrees. Does that make sense to you? 30 degrees is small. It's like this, right? But if the angle's facing this way, it's not 140 degrees. It's just 40 degrees. So in this case, when the angle comes from the right side like this, you're going to use the inner scale. So right side at 0, you're going to use the inner scale. And when the 0 is on the left side, you're going to use the outer scale to measure. Does that make sense to you?
Mm-hmm.
Okay, so number 9 is going to be what?
It's going to be the outer scale.
Yeah, so what would our angle measurement be?
50.
And how about number 10?
That would be 150.
Yep.
No, that's 160.
Yep. So we would use the outer scale and it would be 160. All right. Now we have a few different angles. So you would use a protractor to try to figure out how much this angle is. And let's go over a few of the angles that we have. So the first type of angle is like an L, and it is called a right angle. The second type of angle we have is a straight line, and this is called a straight angle. A right angle is always 90 degrees, and a straight angle is always 180 degrees. Anything that is smaller than a right angle, so anything from 1 degree to 89 degrees is called an acute angle, and you can remember it by, isn't that a cute little angle? So acute we can remember as less than a right angle because it's acute angle. Get it? It's so cute. Anything that is larger than a right angle, so 91 degrees all the way up to 179 degrees, because we know 180 is our straight angle, that is called an obtuse angle. Does that make sense to you?
Sorta.
Okay. So a right angle is an L shape. It's only an L shape. So if it was like this, like a little bit, see how this isn't exactly straight up and down? This would be an obtuse angle. And if it was just a little bit, here would be my obtuse. I'm sorry, this is my straight angle. Oh my gosh, right angle, sorry. If the angle was like this, just a little bit off, but it was inside of the L shape, then this would be an acute angle. And then anything on this side would be an obtuse angle. Does that make sense? So this is a straight angle, a right angle. I am so sorry, I keep saying that. Anything that is smaller than an L, like this, would be an acute angle. And anything that's a little bit bigger would be an obtuse angle. So the only thing that we have for a right angle is a perfectly straight L. That's the only way it could be a right angle. And then we would use a protractor to figure out what that is. So they're going to do two things. They're going to have you measure an angle that is already existing, like this. And then the other thing is they're going to have you draw an angle. So since this is at the 0, if we're going to draw a 70-degree angle, we know that that's going to be this inner circle, inner scale right here, right? So we're going to mark 70, and we're going to make a line, and that would be 70 degrees. Does that make sense to you? And we know that this is 90. We know that this is 90 degrees because it's a perfectly straight up and down L. So doesn't 70 have to be smaller? So we could always check it.
That's an obtuse.
This is an acute because it's, oh, it's so cute. It's smaller than a right angle.
And then it was like 110.
Yeah.
Or 70, yeah. Or 70, it would be an obtuse.
So 70, 71, 72, 73, all the way up to 89. So 1 degree to 89 degrees is an acute angle. And then this one says draw 147. So we know that it's going to be an obtuse angle because it's bigger than 90 degrees. And we know that we're going to use which side? Outer or inner? So we're going to use outer, and we're going to go to 147. And that would be our angle. Kind of makes sense a little bit?
Sorta.
Okay. You can rewatch the video. It takes a little bit of time. All right. So this is turns and right angles. So they're asking if you have a right angle and you turn it so that it is now this angle, how many degrees would that be? So basically you have a 90-degree angle and you're making it go like this, and you're basically folding it down another 90 degrees. So we have the first 90-degree angle plus a second 90-degree angle because we're basically folding it down. Does that make sense?
So it's a 180-degree angle?
Exactly. And we know that a 180-degree angle is a straight line. So basically what that looks like is you have a right angle like this, right? This is a right angle because it's an L shape. See that L? Right?
No.
So this is 90 degrees right here because it's like an L shape. And then we fold it down another 90 degrees and it becomes a flat piece of paper. We know that a straight angle is 90 degrees plus 90 degrees, 180 degrees. Make sense? So for every round that you turn, here's a 90-degree angle. Now they're going to turn it 1 degree. This is 90 plus 90 plus 90. So this is 90 plus 90 plus 90, or 90 times 3. This is 270 degrees. If they turned it all the way around, it would be 90 plus 90 plus 90 plus 90, and that would be a circle, which is 360 degrees. And we know 90 times 4 is 360 degrees. So each quarter turn that you turn is 90 degrees. A half a turn is 180 degrees. 3/4 of a turn is 270, and all the way around is 360. And so we would fill in a circle turn, or a complete turn is 360 degrees. Kind of makes sense?
Yeah.
All right. All right, any questions?